an intersection at Thomasville, Oregon. Shh. All right, car. If you haven't done this if you want to check, if you already done it, that's fine. But if you want to plug it in the calculator, that'd be good. Cars turn left at this rate. Cars per hour over the time interval shown above. The graph of L of t is shown above. And so, when is it the busiest at that intersection, obviously? Yeah, 14, 15-ish. That's when the most cars, there's cars turning per hour. Right here, there's a lot of cars in that hour that are turning. That's the greatest anyways. To the nearest whole number, and this is so much like the other problems we've done. It's like the amusement park problem we did. It's like the sandy beach problem we did. It's like the cars problem we did last week with the traffic flow. How many of you seeing the repetitiveness now? Okay? All right, to the nearest whole number, find the number of cars turning left at the intersection over the time interval from 0 to 18. How do we calculate this?
0 to 18.
0 to 18 of? Why don't we need absolute values?
Because it's
always above the x-axis. It's never going to be, you can't have negative cars turning left. So obviously it has to be above the x-axis. What did you get for an answer here?
100,000. Yeah, pick that number. 58. I said that wrong right away.
58 what?
Cars.
Cars turning what?
Left.
Turning left. All right. That right there was 3 points.
Yep. What do you got?
2 or 3 points, something like that.
It's 3.
It is.
You have
Okay.
to have, what if you're
Traffic engineers will consider the restrictions when L of t is greater than or equal to 150 cars per hour. Turn restrictions, and that's when you get protected turns and stuff like that. Find all values of t for which L of t is greater than or equal to 150, and compute the average value. Okay, average value. What's average value?
1
Times the definite integral from a to b of f of x dx. Indicate the units of measure. All right, traffic engineers. This is an interesting problem because it applies a little bit of pre-calc algebra. It says traffic engineers will consider the restrictions when L of t is greater than or equal to 150. All right, 150 is right here. Whenever we're greater than 150, that's when they're going to consider the restrictions. You need to figure out when that happens first. How can I use my calculator to figure out when we're greater than 150? I know when we're above 150, but I got to be able to figure out when we're, answer the question, when we're at 150. How can you use the calculator to figure out when we're at 150?
You set that
Window.
50 equal to
Yes. You take this equation, L of t, and you set it equal to 150. So, how can you use your calculator to solve that without doing it by hand?
Trace.
Is that equal?
Trace.
Josh, you tell me. I'm one person.
I was gonna say the other way you could do it was you could set y equal to 150 and then see where they intersect.
That's exactly what I want you to say.
Mm.
Okay? To solve this equation, that's exactly what I want. To solve this equation by hand, would that be a lot of work? Yeah, if you had to take 60 root t sine squared t over 3, I don't even know if, I'm sure I could probably do it, but I think it'd be pretty difficult to do. Okay? You might be able to do it by hand, but the thing is you don't need to do it by hand. So Josh is exactly right. What you do is you put your L of t into y1, and then in y2 you put your 150, and you do what we just did on problem 1. You hit second trace, number 5, and find the intersection points. Now, you already know what the y value is. It's 150. You need to know what those x values are. So I need to know what those x are. Hit second trace, number 5, intersect, and give me those 2 intersection points. You have to do both of them.
Y max at least.
Oh yeah, you might have to change your window. Let me give you a hint, guys, here. This is a sine graph. Sine graphs usually have amplitude. It's sine squared, so it's always above. Where's the amplitude at? 60. What I would do is I'd match my window up exactly the same way they had it. I would have went my x min 0, my x max 18, my y min 0, and my y max 300 or whatever they have there. 250, I don't know if 250 is the highest. 300. I would have changed my window and I'd made my graph on my graphing calculator look exactly like what's on the test. You could do that, right? X min, x max, y min, y max.
This thing's working hard. Why is my Y not working? My
What's
Y
XCL?
X scale, never use it. Don't worry.
Okay.
Yeah, mine's not working.
Neither is mine.
I skip fast. Mine has
Just like a
some.
little line of it.
Yeah, that's what I have. I
It's
might.
just like I said, you got to change your window. Have to change your window.
Mine's working.
Your calculator. You're
Mine
in
works
your
perfect.
change it
Brandon
radians.
wants to see it.
Stupid
Hey,
physics.
hey, you people, physics people, you better get your calculators in radians. Okay,
People.
all physics people, get your calculator in radians.
Yeah.
You're gonna be messed up all day.
Dang it, physics. That's what I was struggling too the other day, like just earlier today. I'm like, why is my calculator not working for physics?
All right, what do you got?
The first point is 12.428.
12.428. What's the next one?
I didn't get it yet.
Second trace number 5. You should be doing this. 16 point what? And you don't have to do both of them. Just do one to make sure you know how to do it. All right, now we did that. Let's go back to the question. Traffic engineers will consider turn restrictions when L of t is greater than or equal to 150. Now listen, everybody focus now. Find all values of t for which L of t is greater than or equal to 150. Well, we can say it's greater than or equal to 150 from 12.428. So L of t is greater than or equal to 150 from 12.428 to 16.121. And you might write it like this, 12.428. I think on the AP exam answer key, I imagine they write it like this, but you can use the interval notation. 16.121. That's another way to write it. You could write it as a compound inequality. Hours. And compute the average value. Now what do? That's the easy part. Yeah, this is where we go 1 over, ready? Calculator does the rest of it now. 16.121 minus 12.428. That'll need to be in parentheses. Times the definite integral from 12.428 to 16.121. I'll tell you something on the test you're allowed to do here in a second. L of t dt. And that should be cars per what? Hour. Should be cars per hour. What do you get here? Part B, what do you get? Calm down, please.
His graph is really weird. It's upside down.
What do you got for an answer?
Do you have to write, can we just write 1 over b minus a? Or do we have to write the
Square's in the
actual?
wrong place. Yes, it is. You're squaring the x over 3. The square needs to be outside the sign.
What? Can you just write
Oh.
like 1 over b minus a,
I
like
got
write the
it.
equation down? Or do you have to write the actual
199.431.
points in?
You got to write the points in. What?
199.431.
199.431. Good. Cars per hour. The reason it's cars per hour, listen, it's cars per hour for L of t. This is hours, so hours cancel, but you're dividing by hours again. Now, here's what you can do to avoid. I haven't told you you could do this, but now you can if you think to do it. If you want, you can label these intersections. You can make your own labels, and you can say, this right here is A, this right here is B, this right here is C, this right here is D. Well, that'd be also C, I guess,
Yeah.
since they're same. And you can label them, and if you want to do that, if you want to say A is this one, then every time you see the 12.481, you can use A. But you have to label and tell them
On
that's
the
what you're
test,
using.
you can
You're
do
allowed
that.
to do that if you want. It's up to you. All right, traffic engineers will install a signal if there's any 2-hour time interval during which the product of the number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. In every 2-hour time interval, 500 oncoming cars travel straight through the intersection. Does this intersection require a traffic signal? Explain your reasoning that leads to your conclusion. All right. Well, think about this. If you need to get to 200,000 cars traveling through the intersection during a 2-hour time period, okay? And it's the product of total number of cars turning left and total number of oncoming cars. Now, they say every 2 hours, how many oncoming cars go straight through? 500,000. So if I take 200,000,
500.
Just 500.
200,000 it looks like this. Let me write it up here so you can see it better. Okay? If 200,000 is the total, we got to be greater than this. Okay?
Is that just turning left?
We need to be greater than or equal to that. The product of cars turning left, which would be in a 2-hour time period, so the definite integral from A to B of L of t dt. Does that represent how many cars are turning left
Yes.
from A to B? And if we want to just do time intervals, we'll just take them on 2 time intervals. Times how many cars are coming straight through?
500.
500. Now, if I divide 200,000 by 500, what are you going to get? 400, right? So I need to look, is there any 2-hour time period where the cars turning left is going to be greater than 400? Is there any 2-hour time period where the displacement is going to be greater than 400?
We just did.
Where is that going to be?
It'd be, 13 to 14.
Looks like
Or
it's going to be
13
between
to
13 to what?
16.
13 to 15? So you just got to check it. And just got to say, you got to give an example. It says, explain the reason it leads to your answer. Does this? So you just got to find one place where it's going to be greater than 400. So just get your calculator out. What was it? I think they had you do, no, they did total cars. So 13 to 15, what would it be? Check it real quick. L of t dt, you should have the LT already in. Is 13 to 15 greater than or equal to 500 or 400?
Yes.
What is it?
431.
There you go. That's enough. You just need to find one place where it's greater than or equal to 400. Make sense?
When we looked on one of the answer keys, it said they found the maximum at 14.294, and it went down one and up one as the
You could do that too. I don't even know
How
if
would you find the maximum though?
the maximum you would have to take L of t and
See where it's.
see, you would have to find the derivative of L of t. So the derivative of L of t, you have to see where L prime of t is equal to 0. So you'd have to graph its derivative, or you'd have to find its derivative by hand. Okay? So the way you could graph the derivative is you could go into y2, and you could do your math 8, and put y1, and then you go x equals x. Or for you go comma, x, or you have the new one now. So you just go x equals x, derivative x equals x. And then it graphs the derivative, and you look see where the derivative crosses the x-axis, and you get the maximum there. And then just go one above and one below. But this to me is pretty easy to look at it and say, we know it's going to be at a maximum there. So just go one to the left, one to the right. Or, wait a second here. We got it. Don't we have a graph on y equals? Do we have LT in there? I'll show you something you haven't done yet. I just thought of it. Without using calculus, we can find a maximum. Here we go. Has everybody got a graph? Can everybody see it?
Yeah.
Press graph.
Hold up.
You ready? This is new. Never shown you. It's pretty cool. It's simple. You'll be like, oh yeah, duh, we should have known this before. Hit second trace. Hit second trace. Maximum. What number is maximum?
4.
Number 4. Go right there. It's going to ask the same questions it does for a 0. Left bound, right bound, guess.
Which one do you do for left bound then? Just
Go to the left of the maximum. So you'll be like,
okay.
if we think it's at 14, go a little bit to the left, like 13. Right bound, like above 14. Just put it. You'll put probably your left bound here, your right bound here, and then your guess right there, and then hit enter. Should get the
Okay, so
maximum.
we should do
Yeah,
trace
that's
and then try.
Second trace.
Okay, so second trace.
What number's maximum?
4.
4.
Roll.
And so that's the maximum, and then what they did is they said, okay, if the total number of cars turning left, from there just go one to the left, one to the right. That's going to be the greatest. So if it's above 400, we found the place where it's going to be the greatest. So if it's above 400, we know we need a traffic. All right, next problem. Next problem, this is an FTC one. This is a fun FTC one. There was one like this, very similar, and my kids didn't do well on it last year. Okay, so I need to make sure I do this one and hammer this home. These problems have become the most popular problems, I think, in the last, like I said, 2006. They've done a lot of stuff like this since then. Okay, I can't find a lot of stuff before 2006 that are like this. All right, the graph above is shown of 6 line segments. Let g be the function. G of x is equal to the definite integral from 0 to x of f of t dt. Find g of 4, g prime of 4, and g double prime of 4. All right, g of 4. This is the graph of f. G is what?
G prime. It's the area under the curve.
It's the area under f. Since they told us that we have 6 line segments, you can expect that you're going to have to do some geometry here. Areas of trapezoids, triangles, maybe semicircles, maybe squares, rectangles, something like that. Don't see any arches, so no semicircles this time. All right, we want the area from 0 to x. G of 4. That would be the area from what?
0 to 4.
0 to 4, f of t dt. So from 0 to 4, we're going to be from here up to here. This area is going to be what? Since it's not, it doesn't say area of the region, we're just calculating a definite integral. So now our area can be negative or positive. Let me go ahead and clarify that. And look at me right now and ask me if that doesn't make sense to you. If they do area of the region, we do top minus bottom, and it's always what? But if they're just asking you to calculate a definite integral, they're not asking you to do area of the region. This means displacement. Displacement can be positive or negative. Does that make sense? Okay? So 0 to 4, we got this triangle here. What's the area of that guy?
Be 1.
That area is
-1.
-1, and then we've got all this area of this trapezoid. What's the area of this trapezoid? Its height is 4, its base,
4.
sorry, got that wrong.
Yeah.
These are the bases. It's got a base of 1, a base of 4, and a height of 2, like you guys said. 1/2 base times height.
That's a 4 on the bottom, or 3 on the bottom.
3, yeah, I looked at the 4, sorry. All right, so it's 1/2 the height, which is 2 times the sum of the bases, which is 1 plus 3. Half of 2 is 1. What's the area? So this area is a total of 4, and this area is a total of, what was it?
-1.
-1. Sorry.
Screw it up.
So what's G of 4 then? 3.
3.
Okay? G prime of 4. Well, it helped to know what G prime of x is. What is G prime of x? FTC part 1. Just plug what in? So when I find G prime of 4, it's going to be the same thing as F of 4, which is what?
0.
Well, you're looking at F. F of 4 is just the point at 4, so be 0. G double prime of 4. If I want to look at G double prime, I got to look at what?
Slopes of F.
G double prime of x is F prime of x. So I got to look at the slopes of F. So at 4, what's the slope of the slide? Well, it's down
Down 2.
4,
Oh.
right 2.
-2.
Or yeah, you could have went down 2, right 1. So what is it?
-2.
-2. Slopes.
Out of 3, easy.
Okay.
How do we know?
Because you FTC part 1, plug in x. Derivative rule for the area function. Does G have a relative min, relative max, or neither at x equals 1? Justify your answer. So at x equals 1. Since this is the derivative of G, we're just checking 1. So I don't even know if there's a point to writing much down. I'm just checking 1. Since this is the derivative, below means what? Means the derivative's what? Negative. Above means what? So if it goes from negative to positive, what is it? Negative to positive. Negative means decreasing. Positive means increasing. So it's a what? This is a min. So it'd be a min, and you would have to say this would be 2 points. It'd be a min at x equals 1 because G prime goes from what? You need to say G prime goes from negative to positive, or you could say F.
Can you just say because slopes change from?
You can't just say they change. You got to say how they change.
You say G prime goes from.
Yeah, you can't say G because this isn't G. That's F. You have to say F goes from below to above. Okay? You got to say G prime or F. You got. And the only reason we're allowed to do that is because F is G prime. So you got to say something about G prime, which is F. You can say below to above, but I told you to kind of stray away from that and say that it goes from what? Negative to positive. Okay? Because I can't comment on for sure if they accept. I imagine they do accept from below to above. I just don't want to steer you the wrong way if they don't. Okay? Part C. This would be worth 2 points. So that's 3, 5. Suppose that F is defined. So we have 4 points on this last part to get. Suppose that F is defined for all real numbers x and is periodic. Okay, this is interesting. This is a thinking question. So periodic means this is just going to repeat. Okay? So suppose F is defined for all real numbers x and is periodic. That means we're going to keep seeing the same pattern over and over and over again forever. How long does it take to repeat, guys? 5. It takes 5 to repeat. This thing is cyclic. So every 5 units, we're going to get this same deal. Repeating, cyclic, cycle, iterative, whatever you want to use. Okay, so it's a period of length 5. The graph above shows 2 periods of F. Given that g of 5 equals 2, that's a start, by the way. This one's interesting. This is why it's mega points. Find g of 10 and write an expression for the line tangent to the graph of g at x equals 108. I think this is one of the coolest problems. Huh?
Like the first part was easier than the one
I
oh
got
eight.
the first two.
You think the 108's easier?
No, it's harder. Not
There's a period of 5. We
Okay,
tried
well, we'll see.
solving it, and we thought we had it right, and then we looked at the key, and we were so off. We're like, there's no way we're wrong.
You ready for me to help you?
You go from
Okay, here we go.
almost
Tell me if you don't
five
understand it.
But
Okay, stop if you don't understand. All right, they want you to find g of 10. Remember what I told you guys? Anytime they want you to find a function value and you're given its derivative, all you have to do to get back to the original function at a specific value is go start plus displacement. I cannot tell you enough. You don't need to find no plus c because you're only interested in how many values. One. The only time you're interested in all the values is when they say solve a differential equation. That's when you should go and find a plus c. If they're only interested in one specific value, then forget finding the solution to the differential equation and trying to find the original equation. I don't need the original equation. I just want a 1 point value. So I want g of 10. Well, I need to know the start plus displacement. All right, are you ready? They gave you a start. What is the start they gave you? G of 5 is 2. Now it's important to see what time it starts at, because it does not start at x equals 0. It started at x equals what? But it's like since this thing is cyclic, it's going to keep repeating itself. It's kind of like it is starting at 0. Anyways, but kind of, because every 5 it's going to do what? It's going to repeat, but it's going to keep adding on the same displacement. So let's say the displacement over 5 is 4. Let's say displacement over 5 is 4. That means at 10, if you're at 2 now and the displacement over 5 is 4, that means you would be at what at 10? Okay, let's say that again.
4.
All right, here we go. You're at 2 right now, and the displacement over 5 is 4. So if you're at 2 right now and the displacement over 5 units is 4, what are you going to be at 10? 6. There you go. Another 5. What are you going to be at?
Are we at 20 now?
So pay attention to the problem a
Can
second.
you write it out?
Wait,
Alright.
so
You're at 2 now, and I'm saying the displacement over 5 units. Let's say we know what this is. I don't know what it is yet. We'll
Okay.
find it out in a second. Well, heck, let's just find it out right now. So we'll
Okay.
work with it. What's it's -1 right now.
Yep. Yeah.
This was 4.
Yep.
What's this guy?
-1.
-1. So what's the total displacement from 0 to 5?
2.
2.
It gave us
Did it? Where?
G of 5 is 2.
Oh, it does. Yeah, it does. Give us the displacement. So total displacement's 2. So let's say we're at 2. So then another 5, we're going to add on another what?
2.
And another 5, we're going to add on another what?
2.
And another 5, we're going to add on another what?
No, you're just going to take
So
one
you
and
just
divide
keep
it
go-
by 5.
Exactly. So let's start with this one. Start value is 2. Now here's the points they gave you. I'm going to show you how they give you points here. Start value is 2. And I want to know the displacement. I want to know what it's at 10. But here's the key. You ready? You're going to have a definite integral. Where did this definite integral start at if they gave us a start value of 2 at 5? 5 to 10 of f of t dt. And we already know what this is because it's repetitive. If from 0 to 5 it was 2, what is it going to be from 5 to 10? 2 again. So it's just 2 plus 2, which is 4. So g of 10 is 4. Now, since we know we're going to keep adding on 2 forever and ever and ever and ever and ever, I just need to know how many 2's I'm going to add on all the way up to 108. Because here's the deal, guys.
21, and then there's 3 left over, so now you have to find the
We'll have to find partial displacement. Exactly right.
2 because from
It's going to be
1
to 3 up there.
it's going to be from 1.
All right, so now that you understand, let me explain it to the whole class, because a couple of you are already thinking about it. If I want to get g of 108, if I want to find the tangent line and g of 108, I need 2 things. What do you need? I'm going to need a point and the what? Slope. I'm going to need a point and the slope. I need both of those. Now, to find the point, it's actually a lot easier than you think. Okay? Because all I got to do is I know where I'm at 5. I'm at 2. I just got to know how many 2's I'm going to add on. So at 5, or let's just even start at 0. G of 0 is what? 0. How many times if the cyclic pattern is 5, how many times it's going to repeat if it repeats every 5? How many times is 5 going to 108? 21 times with a remainder of what? 3. So you're going to repeat this thing 21 times. 1, 2, 3, 4, 5, 6. Every time you're going to gather 2. So 21 times 2 is what? 42. So we're up to 42. Now we got to add on up to what?
3.
Whatever that displacement is, up to 3.
So it's 3.
These two will cancel because that's -1, that's +1. So it's really just going to be whatever that is. 2. So you're going to add on another what? 2. So what are you up to? 44. So G of 108 is 44. You don't even have to show work for that. You can just use the fact that it's periodic. Now, G prime of 108 a little bit tricky, but again, it's periodic. If you know it's periodic, this is actually it's easier. Okay? It's going to repeat how many times? 21 times, and it'll be where? At 108, at 3. Now, G prime of 108, you don't want slope, is really F of 108.
Oh, it's the point there.
It's just the point at 3, which is what? 2. We've got the point, we got the slope. So it's y minus 44 equals 2 times x minus 108.
Wow.
I don't know if I've ever seen another problem like that before on the exam. It's just kind of different. I'm not going to spend a lot of time talking about it more than that. Let's go. Keep going. All right, no calculator now. No calculator. Get rid of the calculator for a minute. Here we go. Rocket A has the velocity. As soon as we get out with this first time, take a little bathroom break. I'll come back and talk about dinner, and then we're going to start airing volumes. And then after we do airing volume, then we'll eat dinner.
What do we do after that?
And then after that, we're going to do some more stuff till 8 o'clock.
Like, cook the burrito.
I don't know yet. We'll talk about it. I call Pizza Hut, and it's not going to work like I thought it would. All right, rocket A has positive velocity. Shh. V of t. I got a couple ideas if you want to do. All right, rocket A has a positive velocity V of t. After being launched upward from an initial height of 0. All right, this is key. Initial height of 0 at t equals 0 seconds. The velocity of the rocket is for selected t values from 0 to 80 seconds given in the table above. Find the average acceleration. What do you have? So if I want to go down a derivative, but I want average, they're really asking you to do what? Estimate the derivative. They're asking you for a 9th grade slope here. You have velocity. Now some of you, if they ask for average velocity, since we have velocity, that would be an average value problem. Okay? But since they're wanting you to go down a derivative and find the average going down one derivative, they're asking you to estimate the derivative. That's 9th grade slope from 0 to 80.
No.
No, it's going up. It's going to antiderivative. You back to position. Velocity's down. So, gotcha. Yeah, take another derivative. Okay? All right, so 0 to 80. So you take 2 points. 0, 5, 80, 49. Find the slope. So it's going to be 49 minus 5 over 80 minus 0. Whatever that's going to be. It's going to be 44 over 80, which 11 20ths. What would the units be? Feet per second squared. There is units on this point, on this problem. On a velocity particle motion problems, there's going to be unit points. And if you miss the units one place, you're going to miss them. All right, use correct units. Explain the meaning from 10 to 7 of v of t dt. This is antiderivative. Now we're going up, which gets you back to position. And we know this really calculates what? Area in the curve, which is what, though? What does it mean?
How far the rocket travel?
All right. Yep, how far the rocket travels. Use a midpoint. Use a midpoint Riemann sum with 3 subintervals. This right here is so important. It's not always equal length. When it is equal length, it's nice. Okay? So what I'm going to do here, I'll show this work here so you can make sure you get this. I want from 10 to 70, and this is the way I would set it up. You're estimating. Anytime we use a Riemann sum, we're estimating an integral. Okay? You do 9th grade slope to estimate a derivative. You do a Riemann sum or a trapezoid to estimate an integral. So I want 3 subintervals. You have to divide it yourself. So it's from 0 to 80, and it's equal.
10 to
So
70.
it's 80. 10 to 70, thank you. We only got to go from 10 to 70, and I've got to do 3 subintervals of equal length.
0.
Oh, it's 10 to 70. I'm not even reading the problem. Sorry. 10 to 70.
Yeah, bro.
All right, so we're gonna get. You can probably get it with. You can probably just eyeball the intervals, but if you don't, you can take the whole interval and divide it by 3. How many subintervals you want? Which is gonna be 70 minus 10 over 3. So it's gonna be 60 divided by 3, which is 20. Most of you could have just eyeballed it and saw. Saw that you're gonna have to have one rectangle there, another rectangle here, and another rectangle there. Now I want to use a midpoint. First of all, let's talk about what's the width of every rectangle going to be. 20. And since it's equal length, that means I can throw the 20 out front and multiply all the heights by 20. I don't have to put the 20 in there because remember, rectangles, it's just the width times the height. So the width's all 20. 20, 20, 20. Now I get the height. First midpoint from 10 to 30. What's the midpoint? But what's the value you're going to use? You're going to actually use the 22. Now, on the AP exam, I've seen the answer key 2 ways. Some people put V of 20. They do their label. And then that's all you have to do, and then you just type, well, this is non-calculator, isn't it? Okay? Okay, then this next one,
Thanks, Jake.
thank you, Jake.
Hollows.
Then it's V of 40 plus V of 60. Now, I think they're okay with you guys just putting in the value. So V of 20 is what? 22 plus V of 40 is what? 35 plus V of 60 is what? 44. This is non-calculator, so you're going to have to add this up. You can add those up pretty easy. 66 plus 35 is what? 10 what? 101 times 20? 2020? Is that right? So we get, this is approximately 2020. What does it mean? Feet. 2020 feet. This is how far. You would have to say something along the lines. It says, explain the meaning. So you need to say, this is how far the rocket travels. Okay?
Wow.
Rocket B,
Let's go far.
I'm pretty sure this one's only going to be 2 points. This one's probably going to be 3, and this one's probably going to be 4. Rocket B is launched upward with acceleration of A of t is equal to 3 over square root of t plus 1 feet per second. At time t equals 0, the initial height of the rocket is 0. Okay, that's important. And the initial velocity is 2. Now, they're giving you this for a reason. They're giving you the position of the rocket at 0 seconds. They're saying its position at 0 is 0. They're giving you its initial velocity. They're saying initial velocity is what? 2. Which of the 2 rockets is traveling faster at t equals 80 seconds? Explain your answer. Go ahead, question.
How can they say it's at 0 when it says it's at 5 feet per second?
That's rocket A up there.
Ah, okay.
We're on rocket B.
That answers my question.
Gotcha.
Okay? Totally different rocket here. Alright? So, here's what you're going to do. You're going, which of the 2 rockets is traveling faster at 80 seconds? Explain your answer. I don't even know if we need the initial height here. At 80 seconds, rocket A is traveling how fast? So we know how fast it's traveling. What I need to do is figure out how fast rocket B is traveling at 80 seconds. So what you can do here, this one is non-calculator, so let me show some work on this one. Let me zoom out. Need a little more room. You're going to have to solve a differential equation on this one. Okay, you don't have a choice. And that's the reason they gave you the initial velocity. So I'm going to have to go back to the velocity for rocket B. So here we go. Rocket B. We already know what rocket A's velocity is at 80 seconds. I want to know which one's traveling faster at 80 seconds. So rocket B. So I want to know if I've got A of t. This is probably what I would do. There's 2 routes you can go here. It's kind of up to you which route you want to go. A of t is 3 over the square root of t plus 1. So I want to find velocity. How do you find velocity then? Take the integral of both sides. So we're going to have the integral of A of t is what? There is a plus c, but we'll do what with it? Throw it to the other side. And this right here, you technically could say you need u substitution, but do you really need it? No, because you can throw the 3 out front. 1 over the square root of t plus 1 dt. And if you let u equal t plus 1, dt is just, du is just going to be dt. So is it really necessary to do u substitution on this? No. So it's going to be 3 times the definite integral of t plus 1 to the negative 1/2 dt. All right, add 1 back to the exponent. What are you going to get? T plus 1 to the 1/2. Multiply by the reciprocal, which is
2.
6. Multiply by 2 plus c. There's your v of t. Now what do? What do you do to get the c?
Plug in
We could just do
the 0 and 2.
Use the fact that the initial velocity is 2 feet per second, which means at 0 seconds, v of 0 is 2.
Can you just plug it in?
You plug it in. You can't just put 2 in for c.
No. I'm talking about put 0 in.
Yep, that's what we want to do. So we want to set it equal to 2 and put 0 in. That's right. So you're going to get 0 plus 1 to the 1/2 plus c. That's going to be 1 to the 1/2. Let's square to 1. 1 times 6. 6. Move the 6 over. What's c equal?
Wait, whoa. T equals C?
Yeah.
Negative 4. What you need?
1 times 6.
Think of what? Because they gave it to you. The only way you can ever solve for a plus c, they have to give you a point for that equation. So that's for velocity because it said initial velocity is 2. So initial means at time 0. Okay? There is a different way to do it. I'm not saying this is one way to do it. And some of you like this way, and I'll show you one other way, and you can kind of pick. Now, once you get your plus c, or once you get your c, now you've got your v of t for the rocket B. So v of t is equal to 6 times t plus 1 to the 1/2 minus 4. Can you find v of 80 now?
Yes.
You can. V of 80. Then I'm going to tell you the way I prefer. And then you can decide which way you like. And then you've got 2 ways to do it. 80 plus 1, notice it's non-calculator. It's going to work out fairly nice. 80 plus 1, square root of 81. 9 times 6, 54 minus 4. What's the velocity for rocket B at 80? 50 feet per second. Which one's moving faster? Rocket B. Now, look at all that work. If you're only interested in v of 80, you could have done your start plus displacement that I've been trying to tell you to do. And it speeds it up because what it does, it couples the plus c, solving for the plus c, all into the work. It basically takes all these steps and morphs it into one step. If you'll do start plus displacement, what was the start value? What's the start velocity? 2. So it's start plus displacement from 0 to 80 of your velocity, which is, you're not going to get out of doing the integral. You still have to do the integral. Okay, 3 over the square root of t plus 1 dt. You still got to do the integral. I can't get rid of that. But it will go ahead, and instead of having a separate step where you find plus c and then going back and plugging in, it'll just do it all at once. So it go ahead, it already accounts for that initial value, so watch, we'll get the same answer. 2 plus, all right, definite integral. We'll cheat, we already know what it is. What was the integral? 6t, we already know what the integral is here, I'm just going to cheat. But do we have a plus c with the definite integral? No, so it's 6 times t plus 1 to the 1/2 evaluated from 0 to 80. Now watch this. You're going to have the 2 plus 80 plus 1, still 9. 9 times 6 is what? 54 minus, put in the 0. 0 plus 1 is square root of 1. 1 times 6. 54 minus 6. What's 54 minus 6? 48. 48 plus 2. Still you got 50. I like that way better personally, but preference up to you. If you think, man, I just really have a hard time recognizing when I can do start plus displacement, but always remember I can get an equation, find a plus c, and plug it in. That works too. Either way is valid. And they, on the answer key, they actually show both ways. Yes?
If they gave us a different point that wasn't the start, then you can do it your way.
No, if they gave me the velocity at 2, which is 50, I still could do it. What you would do is you'd set, let's say the velocity at 2 seconds, let's say it was 10. Then what you would do is your 10 would be here, and then you do, instead of, it wouldn't be from 0 to 80, it'd be from 2 to 80. Your start is based on wherever you measure from. You know, you measure your birthday from 1990, whatever. This would be measured from 2. Your start is whatever you measure from. So here I'm measuring from 0. That's why it was from 0 to 80. if I gave you a different value, v of 2 equals 10, your start value is 10, but I'm measuring from 2, so it'd be from 2 to 8. Huh? It could still be a point. It's a point on the graph. It's a start value at 2 seconds. Maybe you only know where it's at 2 seconds. You get to set your start. Everybody starts different for their life. It still works, trust me. You'll see it. You can come back to that and probably see it again tonight. All right, next problem. We'll see it again, I guarantee you. Maybe I'll. All right, last two here, and then we're going to take a quick break. And then we'll talk about dinner. All right, consider the differential equation of a slope field. I just showed you how to do the slope field last week and the week before on the axes provided. Sketch a slope field for the given differential equation at 8 points. Again, x cannot equal 0, so they don't even do the y-axis here. Notice there's no points there. So you ain't even got to do the x equals 0. Reason is because you get 0 in the denominator. It's undefined. So we do each one of these points. This point, let's start over here, is 1, 0. Put 1 in for x, so you're just going to get a 1 in the denominator. Put a 0 in for y, you're going to get 1 plus 1, so you get 1 over 1, so what's the slope there? 1, so draw it about like that.
One of these dealios.
Okay? Next point, 1, 1. Put a 1 on the bottom for the x, put a 1 on top for the y. Now you get a slope of, you got to make it a little steeper. And then 2, 0, might as well do that one real quick. 2 for the x, 0 for the y. Now we're going to get a half. Now you're going to make it a little less steep than 1. And some of you might worry, oh my gosh, it's just make it look a little bit less steep than whatever.
Do you think they're going to even
They're
have
judging, huh?
Do you think they're going to even have
It hasn't. It's been about every 3 years, and it has been on the last 2.
I hope they do.
Yeah, I hope they do
I
actually.
don't like hard feet. That's not
Okay.
daily.
So slope 45, make it more, less steep. All right, next one. In fact, this will go back and answer Lizzie's question we did, because this one right here is a differential equation. We'll have to do that plus c again. All right, 1, negative 1. Negative 1 is on bottom, 0, so that'll be a slope of 0. So anytime y equals negative 1, what are you going to get? So this one over here is going to be a slope of 0. I think everything's just going to be flip-flopped, isn't it? You're going to get negative 1 on bottom, 0 on top. Isn't this going to be a slope of negative 1 now? Is that going to be a slope of negative 1/2? Is that going to be a slope of negative 2? So steeper.
Drawing your little lines.
Draw my little lines. What do I think it is? I would guess that it is some kind of,
I'd say it's an L.
it's got a horizontal asymptote somewhere.
Right down the chute.
It's got a horizontal asymptote down here, so I'm going to say it's probably got, yeah, it might be a,
vertical asymptote at least.
might be a vertical asymptote, but not necessarily.
Because it, that was,
Could be, could be. It could be a corner or cusp though. Okay, probably like a volcano or
We want to know.
probably a volcano is what I'm guessing. All right, I can't. Find the particular solution. This is the easy part, I think. If you get this right. All right, watch. This is your, okay, this answers that question, Lizzie. Here they're giving you a start value, but it's not starting at 0. A point is considered, listen, anytime they give you an initial condition, it's considered a start value. So your start value here is at 1, and negative 1 is the actual place in time where they're letting that be the start value. So they're saying, because there's only one beginning ever. So everything else is just a random point in history. Okay, there's only one beginning. All right?
How do we know that's the beginning?
Because they say initial condition. So that's your initial point. So don't make it any more complicated. Just think of it like that. That's my initial point. Let's just go with that. All right. Separation of variable. This was probably only worth 2 points in part A. The next part was probably worth 7. Are you ready? This is easy points, easy money right here. You don't even have to get the whole thing right to get a lot of the points. You can probably get 4 to 5 of the points and not be able to finish it. That's why I like this problem, because a lot of you are going to get this first part. All right, what's the first step, everybody? Separation of variables. The x is already on this side. I just got to move the dx over. So the x is going to stay where? On bottom, so it's going to be 1 over x. The dx will come over. But to move the 1 plus y over, what are you going to have to do? Divide by it. So it's going to be 1 over 1 plus y, and then dy. Right there got you 1 point.
Could you do it the other way?
could do it the other way if you
Yeah,
wanted.
so much harder.
But the problem is you got dx on bottom, and you're not allowed to have dx on bottom. You gotta get dx and dy cannot be in the denominator.
Okay.
All right, listen to me. When you solve a differential equation, dx and dy have to be on top, out to the side. So you can go the other way, it's just hard to solve because you got to get the dx and dy on top. All right, next step. That's 1 point. Mega points here now. What do you do? Integral? All right, what is this going to be? You do not need to do a
ln.
substitution for it. ln of 1 plus y, there's 1 point right there. You're up to 2. What's the other side going to be?
ln,
There's 3 points.
You need a
yeah,
plus.
7 plus c.
Plus c is the 4th point. 4 points. Now, some of you are like, that's as far as I could get. Guess what? You've already got 6 points on this. You're more than halfway on this free response. So anything you get here is just cherry on top. Now, I think you can get the plus c. Plus c is not that hard. Solving for y, I think, is the tricky part. Now, you really can decide when you want to plug in for plus c. I tend to wait until I get y solved for. I always say solve for y next. But if you're like, man, I'm not very confident I can solve for y on this one, then here's what I tell you to do. Get your plus c now. Plug in your point now and get your plus c. Because you can. You can plug that point in any time after you've taken that antiderivative to get the plus c. I am going to wait because I'm going to try and finish the problem, actually. All right, here's the deal. If I'm going to do this correctly, this one works out sweet. All right, because you've got 2 ln's in it. If I want to solve for y here, what do I have to do? Go full circle. So it's going to be absolute value of 1 plus y is equal to e to the what? ln absolute value of x plus c. Now, this part we've seen now. Let's see if you remember how to do it. It's going to come up another 4 times in this week.
That's what I don't know how to do.
You got to do what with this power?
Combine them.
What do you mean combine it?
Like
Cancel.
e, absolute value.
E to the ln absolute value of x.
Plus e
Divided?
e plus e to the
E
c.
multiplied?
Times.
Don't say that yet.
E to the
Multiplied?
Times e to the c. Why?
Is this a property with the
It's a property. If the powers are added, you can separate the power by multiplying. Because what's the rule when you multiply powers? Add exponents. Now, Sam's right. The reason we did this is because what's going to happen to the e and ln? Cancel. Boom. Drop. Bring the absolute value of x down. Now there's no e's in it. So we've got x times. Now, what are we going to call e to the c since it's just a constant? You can keep doing that until you do what?
Plug in.
Until you plug in, you can just keep renaming it what? All that. Now, in the AP exam, they rename it a new one called K or C2, but it doesn't matter. It is absolute value of x. Now we'll ditch that in a second.
What times c?
Times C, yep,
Why is it times c?
because time's right there. Okay? Let's plug in now. Plug in our 1 for y. What's 1 plus 1? What's the absolute value of 2? 2 equals absolute value of -1 times c. So c equals what? There's a 6 point. Now, or
7. That'd be 7.
Morris,
Can you redo that?
Morris, how did we ditch the E?
hold on. 1, 2, 3, 4. This is their 5th point. I'll show you how to get the last. Huh?
Morris,
The first 7 is 2 on top.
That's our 7th because the graph.
Oh yeah, total. I'm talking about this part B. I'm trying to keep up points on part B. So we're up to 5 points on part B alone. All right, stop me if you don't need something explained. We're gonna do another one like this
How
tonight.
come it can go from C or E power C just to C?
Because you don't know what C is anyways.
So you just
You
okay.
just say it's another, it's just constant. Until you plug in that initial value, you can just keep writing it. It doesn't matter what it is. You can add another constant to it and solve another constant.
Can you write it with the 2?
So now, that's the 5th point. There's 2 more points here to grab. This one was kind of hard because you got your C. Now you got to finish solving it for y. So let me come over here. It was 1 plus y equals absolute value of x times c, which we now know is what?
2.
2. Now watch. We got to solve for y completely. So we're going to have 2 absolute value of x. Now here's the deal. I got to drop the absolute values here.
Square.
No. Just drop the absolute values. But if you drop absolute values, what do you have to do? Who said it? Plus or minus. Thank you. What does that mean?
It could be.
Because it's piecewise. Anytime you have absolute values, you want to drop it, you got to put plus or minus. Now, we're almost done solving for y. What does y equal then?
Equals -1.
There's the 6th point. We're only up to 8. There's one more point, and it's deciding if this is supposed to be plus or minus.
Yeah.
This is why this was 7 points. You go back to your initial point and you check it in your final answer. Check it and say, do I want the positive one or the negative one? All right, let's plug -1 in for x. What's the absolute value of -1? 1. We're going to need 1 times +2 or -2 to get 1 for the final answer. You need a
Negative.
positive 2. Nope, you need a positive 2.
Always go with positive.
Almost, not always. Just plug it in and see which one will work. Watch again, let me say it again. Plug -1 in for x. What's the absolute value of -1? 1. So you go 1 times +2, you get 2. 2 minus 1 is? If you would have done the -2, it would have been absolute value -1's 1. 1 times -2 would have been -2. -2 minus 1 would have been -3. Would that have got you what you needed? No, you need the +2. Question, Lizzie. Only Lizzie talking. Shh.
So you said that after you got rid of those, how is that?
Up here, you could have plugged in? Like, is that what you're asking, if you couldn't have done this?
Said that we could.
You could. The reason I don't is because if you do it here, your C ends up being a little weird. So here's what it'll look like. Shh, 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 shh. Okay, if you'd have plugged it in, you would have had 1 plus 1 would have been 2, so you'd have had natural log of 2, right? And then you'd have had -1, which is natural log of absolute value of -1 is 1, natural log of 1. Plus C, right? And then natural log of 1 is just what? 0. So you get C equals ln2. All right, now, when you get your C equals ln2, you come down here and you start solving. Instead of doing, because we already found our point. Oh, I didn't mean to erase that. That was the part I didn't want to erase, actually. So you found your, and you might actually like this better. If you're paying attention, you might like this better. Because here's what you can do with it. Once you get to here, Lizzie, then when you split it, times e to the c, you split it because you add in the exponents, you split it with power. Now, since you've already plugged in, I can't call this a constant now because I've already found my c. So you put your ln2 in. Look at what happens when you put ln2 in. What's e to the ln2?
2.
E and ln cancel each other, you get your 2.
That seems easier than the other.
So.
Either way you do it, it works. So then you would have got your 1 plus y equals e to the ln absolute value of x times e to the ln2, e and ln, now you got your 2, now we're to the same spot, we're over here. We'd have to,
How? Why?
okay, this is 2, right?
Yeah.
Okay, so 1 plus y equals e to the ln, do what? So we got absolute value of x with your 2, we're right there again. Now you just got to finish solving. Okay. Yep. Yeah, I know, cool. Last one, and we'll take a quick break. Shh. Here we go, last one. The number 6. My kids sucked at this last year. That's why my exam didn't go very well. They did not do good on, like I said, that FTC Part 1. The one we just talked about a minute ago, I think it was number 3 or whatever it was, with the 3 6-line segments, and they didn't do good on this one. And I looked at the 2013, which you're going to take on Thursday, Friday. It was like this, and it was pretty hard. So get used to seeing this, because they've fallen in love. The last 4 years, they skipped a couple of years, but last 4 years it's been on there like this, where it's called symbolic, ready? We've done it, symbolic differentiation and symbolic integration. All right, you got the twice differentiable function f, which means the original function is continuous. The derivative is what? Because if the second derivative is continuous, if it's twice differentiable, everything has to be continuous. Okay? Is defined for all real numbers and satisfies the following conditions. So you got this junk, which is good. That's stuff you need to know. All right. The function g is given by g of x is equal to e to the a to the x power. A is a constant. Okay? Anytime they give you variables like that, they're constants. Plus f of x for all real numbers where a is a constant. Find g prime of 0, g double prime of 0 in terms of a. You okay? Show the word that leads to your answer.
Hot.
All right, here we go. G of x Now, this is a problem where if you don't just start doing step one, if you're sitting there trying to think about how the heck am I going to get g prime of 0 off of this when I don't even know the equations, guys, just do the first derivative and worry about getting the answer later. Do step 1, step 2, and step 3 will reveal themselves as you start working through it. Because you'll, in a second, you're just going to be like, oh, I see what we're going to do. So e a to the x power plus f of x. This actually was a fairly easy one if you know what you're doing. It wasn't real complicated to take the derivative of. There's no product rule, no quotient rule, nothing real complicated here. All right, g prime of x. How do we take the derivative of e to the u? Itself. So it's e to the ax power times the derivative of the exponent, which is just what? Now, you come to f of x. How do we take the derivative of f of x if we don't know what it is? Symbolically, f prime of x.
I thought this was actually really
Good. I didn't think this was that bad. 2013 was a little harder than this one, I thought. Last year's was harder, I thought, because they did have a product rule in it. And you got to remember to factor out the e. All right, now, can you find g prime of 0 now? Absolutely, just start plugging in. Everywhere there's an x, put in a 0. Don't think about it, even if you still don't know how to do it. As soon as you plug in 0, I guarantee you're going to know how to do it. 0, e, a times 0, times a, plus, stop that please, f prime of 0. Now you're probably like, oh, okay, f prime of 0. They gave us that. That makes sense now. What's e to the 0? 1, so you're going to have 1 times a, which is a, plus f prime of 0, which is what? Negative 4, so there's your answer. A minus 4. Did they ask us to solve for a? Do we know what a is? So then we don't care. If they didn't ask you to find a and they didn't tell you what a is, then don't worry about a. Yes, question.
When we took the derivative of g of x, where did we get times a? E to x?
Chain rule.
Oh, okay.
Itself times
G
the
of
derivative.
x is, okay.
All right, now second derivative. Let's go for it. Second derivative. Now, we already have an a there. So again, what's the derivative of e? A to the x again. Itself
times derivative of u.
times the derivative of the exponent, which is what again? But we already have a.
Squared.
So it's going to be a squared now. Plus, what's the derivative of f prime of x? F double prime of x. That's all I can do. Now, let me go ahead and tell you how many points you're going to get for this. You're going to like this. You are going to get a point for the derivative of g, and you're going to get a point for g prime of 0. There's 2. You're going to get a point for g double prime, and you're going to get a point for g double prime of 0. This was 4 points. There'll be 5 on part B.
How'd you get that a squared?
Yeah, where did the a squared come
Wasn't there already an a there?
Yeah.
So itself
Oh, another a times a.
times the derivative of the exponent, so a times a is a squared. Now we go g double prime of 0, which is going to be e to the 0 again, because 0 times a is 0, times a squared, plus f double prime of 0. What's f double prime of 0? 3. So we're going to have, what's the answer? A squared plus 3. There it is. There's g double prime of 0. Good job. Okay. All right, part B. 5 points on this one. The function h is given by, here we go. How many of you got part A with you and your partner? Okay, that was one. And some of you probably ran out of time, didn't get to attempt it. That's okay. How many of you with your partner have already gotten at least half of the multiple response, though? Feel pretty good. Now, here's the thing. That's why I say rock the multiple choice. Rock the multiple choice out. Then you don't have to do, if you get like 60, 70% right in multiple choice, which is I feel like a lot of you are going to do, then you can get to the free response and only get like a third of it. Okay?
Cool.
Yeah. So
Third.
to pass. Now, if your goal is to make 4 and 5, then that's different. All right. Oh, you guys are rocking. I'm not too worried. All right. Here we go. H of x, where k is constant.
Throw it away.
Don't throw it away. That's Jake's. No, but I did that. Oh, Jake, I'll go get all
Got
that.
slob already.
He's caught Juna.
Okay, here we go. All right, the graph of h is given. K is a constant. Find h prime of x and write an equation for the line tangent to h at 0. So I might as well go ahead and know that I'm going to find h of 0 and what else?
The what?
H prime of 0.
Yeah, sure.
Why do I need these two things? Because you always need a what? a point and a slope to be able to find the equation for a tangent line. You need a point and the slope. Point and slope to find the equation for a tangent line. So can you go ahead and find h of 0? Even if you can't do the derivative, and you're like, oh, I don't know how to do the derivative of that because it's product rule and chain rule combined, blah, blah, blah. I can at least do h of 0 and get 1 point. All right, plug in 0. You're going to have cosine. Doesn't matter what k is. Because when we go k times 0, what's going to happen to k? All right, so k times 0 is what? K times 0 is what? What's cosine of 0 in the unit circle? 1 times f of 0 was given. What's f of 0? 2. So there you go. You got 1 point for that. H of 0 is 2. H prime. Here we go. This is where it gets interesting. That's why I think it was worthy to be a free response. What rule do you need to take the derivative of this? Product rule and chain rule. Watch carefully.
Morris,
All right.
we just do the first step and plug 0 in?
Huh?
Is this one of those times where we can just do like, we don't have to simplify the derivative?
Nope, because they told you you had to find H prime of x.
Oh, you actually have to find that.
Yeah, you have to find it. So you get points for finding it and simplifying it. I don't think the simplifying is going to be more than one step here. They don't get caught up in all kinds of algebra, but they do like to see, make sure you know how to do algebra. All right, let's do this. So h prime of x, derivative of the first. All right, it's going to be negative sine kx times what?
K.
Times k times f of x plus f cosine kx times f prime of x.
As far as you can
I think on this one, that's probably as far as you can go. The only thing you might want to do is do what?
bring it up.
Put the k out front, negative k sine kx. Do you have to do that? No, you do not have to. They're probably not going to get too.
Okay, good.
They're not going to get too bent out of shape if you don't do that.
Good.
And the reason you're not going to worry too much about the k is because probably when I throw some zeros in here in a second, the k is going to take care of itself. So don't get your yeah. Get a bunch.
More.
Negative k. All right.
Take it.
Sine of. Here we go. So it's negative k. We're finding h prime of 0 now. By the way, you got a point for finding the derivative. So far we got 1 point for this, 1 point for this. So there's 2. There's 3 more points to grab here. You're going to get 1 more point for finding h prime of 0. So it's going to be k times 0, which is what? 0 times f of 0. Deal with that in a second. Cosine of 0, because k times 0 is 0 again, plus f prime of 0. Now I think this is awesome because what's sine of 0? That's going to be all gone. Times, thank you.
Good job.
So that's 0. What's cosine of 0 again? 1. What's f prime of 0?
-4.
Negative 4, so that'd be 1. So h prime of 0 is negative 4. There was a third point.
Yeah.
Write the equation of the tangent line. So you're going to get y minus 0. No.
Yeah.
No.
No?
Y minus 2,
Yeah.
because the y value is 2.
You're right.
Negative 4 times x minus 0. That's only 1 point. I'm having a hard time seeing where the other point's at.
Oh.
We didn't have to find
You have to simplify. No, you don't have to simplify that.
What? You have to find h of 0,
why.
because you got to have the point.
Did we find h of
H of 0 was 2. We just
in
found
part A? Did we find g's of 0?
No, we did not.
Well, that's part of it.
G has
Or
nothing.
not g, but like g prime of 0.
We did,
Okay. Alright.
but that's not. B is H.
Yeah.
Anything in A did not help you for B.
Yeah, I was just wondering, like, because you were looking for a point.
I don't know where the 9th point's at. There's a 9th point somewhere. Who knows? Who cares? All right, take a quick potty break real quick.
Crushed it. We cranked that last one out. Yeah.